Welcome to Stock Pencil Basic Understanding Concepts. Today we learn about arithmetic progressions. Today's topic is arithmetic progression. So you see more excitement while learning this arithmetic progression. You see really exciting while you are solving the arithmetic progression problems. Let's start what is arithmetic progression. Before starting about arithmetic progression, let's see and observe some of the patterns which you see in our real life. For example, you see the real number starting from the 1, okay? What is the next number? 2, 3, 4, okay? You are clearly seeing that it is following some pattern. But just adding the one number to each number will get the next preceding number, okay? So, I'll give you some more examples in your life, okay? At the age of 5, you have some 1,000 rupees with you. Okay, at the age of 5, you have 1,000 rupees with you. Okay, so every year your father is giving 500 rupees to you. Okay, so at the age of 6, how much money you have? So every year your father is giving 500 rupees to you, right? So it will be 1,000. Next year you will be having 1,500 rupees, right? So next 7th year, how much you will be having? You will be having 2,000 rupees. Right? Similarly, at your age may be currently 14 or something, you have some money. So, you can observe some pattern, right? Every year we are adding to the preceding number 500 here. So, it's following some trend. Similarly, I am writing another series. If you see 1 square, 2 square, 3 square, 4 square, if I keep writing, it is also following some trend. So these are all called the patterns, okay? You are observing in the patterns. I will show you some more examples here. For example, you deposited 100 rupees into the post office, okay? When you have the 5 years old, okay? So the post office is giving you money every 6 years. They are making double the money, okay? So after 6 years, how much money you will be having? 200 rupees. Again, after 6 years, how much money you will be having? 400 rupees. Again, after 6 years, how much money you will be having? 800 rupees. Right? So, every 6 years, they are doubling the money. Okay? So, this is also following some kind of patterns. Okay? So, if you turn to age of the 48 or 50 or 60, you can need to know how much money you will be getting. Okay, so far we are seeing some of the patterns. Okay, now let's see what is the arithmetic progression. So I am going to write some more the series here. Ten, 20, 30, 40, and so on. Another series 7, 5, 3, 1, -1, etc. Other series 3, 3, 3, 3, etc. Okay. Another series 100, 150, 200, 250, etc. So, here I have written some of the patterns or some of the series. We are calling these are the series, and each one is we are calling the term, okay? That I am writing here, it is called the term, okay? Term. Each one we are calling the term, and this is called the series. In this series, this is calling the first term, this is called the second term, third term, fourth term, that way. Okay, so what is the first term in the, let's take, this is the first series, this is the second series, and this is the third series, and this is the fourth series. Okay, let's take from the first series. Okay, what is the first term? First term the 10. Okay, the second term is 20, third term is 30, and fourth term is 40. Let's see the difference between the two terms. Okay, let's take the difference between the two terms. For example, the term 2 and term 1. I'm saying that we are calling term, right? So term 2 minus term 1. Okay. So I'm writing the difference. I'm calling the difference. I'm denoting into the D. Okay. So I'm writing 20 minus 10, right? That is 10. Okay. I'm writing again term 3 minus term 2. Okay. If you observe that way, so that is also 30 minus 20. That is also 10. If you make term 4 minus term 3, that is 40 minus 30. That is also 10. So you are observing one thing, okay? You have the same difference between the two successive numbers, right? So it's following very clear trend that when we add 10 to the preceding number, you will get the next number. For example, these are 10. When you add 10, then you will get the 20. Okay. For the 20, if you add another 10, you will get the 30. For 30, if you add another 10, you will get the 40. So what we are saying, right? You are getting the next number just by adding the difference. This is called the common difference. Okay. What we are calling this is called the common difference. Okay. I am writing the series 2. Okay. If you subtract the second term and minus first term, okay, that is 5 minus 7. That is equal to minus 2, right? Similarly, third term minus second term. This is a third term and this is a second term. 3 minus 5 is equal to minus 2. Similarly, fourth term and third term, okay, that is 1 minus 3 is equal to minus 2. So here also we are just subtracting minus 2 number, then we are getting the next number. In the third series, similarly, we are just adding 0 number or subtracting the 0 number from the previous number, we are getting the next number. So this is also following some kind of pattern, right? So in the fourth series, we need to add 50 number to the preceding number, okay? So that we will get the next number. This is called the arithmetic progression. If you have the fixed number, if you are adding to the preceding number, then we are calling the arithmetic progression, except the first term, okay? First term does not have the preceding number, okay? First term will be there. Any other number other than the first number, you will get just by adding the common difference to the previous number, okay? So an arithmetic progression is list of numbers in which each term is obtained by adding fixed number to the preceding term, except the first term. Don't try to memorize the definitions, okay? In the exam, if you write by your own understanding and with your own words, that's also fine. Sometimes you may get the less marks, that's also fine. The understanding is more important than the just by adding the definitions, okay? So what is your understanding? In arithmetic series, it has the common difference. You know that the difference between the two successive numbers will be the same for the entire series. That's all you know, right? By obtaining any number, just adding this common difference to the preceding number, okay? The first term anyhow does not have the preceding number. That's why you cannot add the common difference to the first number, right? That's what he is explained here. So you understand the concept now here. But while you are writing, you can write in your own words, okay? How can you write? Just adding common difference to the preceding number, obtain the series of numbers, except to the first number. Very simple, right? So common difference, either positive, negative, or 0. If you see our previous examples, we may get the positive number, or we may get the negative number, or it may be the zero number. Okay, these arithmetic progressions are maybe having finite arithmetic progressions or infinite arithmetic progressions. What is finite? Okay, finite arithmetic progression. So I'm just writing the AP. This represents the arithmetic progression. What is finite arithmetic progression? If it has the end number, that's called arithmetic progression with finite numbers. Okay, but what is infinite arithmetic progression? Means it does not have the end number. Okay, so it does not have end number. That we are calling the infinite arithmetic progression. If you know it has the end number. Okay. If you are writing, for example, the real number starting with 1, okay, 1, 2, 3, 4, 5, okay, so it does not have any end number, okay, it will go to the infinity. This kind of series is called the infinite arithmetic progression, okay. For example, particularly you are solving a problem, okay, initially you have the 100 rupees and each year your father is giving the 50 rupees, okay. So at the age of 5 years, okay, you have the 100 rupees and every year he is giving the 50 rupees, so that the next year it will go to 150 rupees, next year it will go to the 200 rupees and at the age of 10 or something, you have the fixed number, right? So then this kind of series we are calling the finite arithmetic progression. Now what we come to so far, we studied the arithmetic progression has the common difference, okay? So it should have the common difference. That common difference is either positive, negative, 0, right? In the series we have the terms. So this is called the first term, this is called the second term, this is called the third term, so on. When you know the end term, this is called the last term of the series. If it does not have any last term that has the infinity, then that's series we are calling infinite arithmetic progression, right? So let us see some example. Okay, so if you know the first term, okay, the first term I'm just denoting with the number A, okay, alphabetic A, okay. So if you know the first term is the 6 and the common difference I'm denoting with the 3, okay. Okay, then question is asked, can you write the arithmetic progression with these two? Yes, you can write. So you know the first number in the arithmetic progression, that is first term, okay. A is equal to 6, here is the first term in the arithmetic progression. So let's write the first term in the arithmetic progression, that is 6, okay. How do you get the next number? Just adding the common difference to the previous number, okay. That is 6 plus 3, right? And how do you get the next number? Just adding the common difference to this one, right? So it is 6 plus 3 plus 3, right? And so on. So it is 6, 9, 12, etc. Okay. Instead of that, you can write something like this. Okay. The first number A1, A is the writing the A1 is the first number is 6. How do you get the A2, the second number? We are taking the previous number like A1 and adding the common difference, that is D, right? So what is the A1? 6 and the common difference is 3. So the A2 term is 9. Okay. How do you get the third term? Okay. So this preceding number is A2 and the common difference is D. So A2 plus D. Okay. What is the A2? 9, right? It is 9, right? Plus adding the common difference 3. So we'll get the third. So how do you write the series? It's A1, A2, A3, so on. Okay. So now the series is 6, 9, 12, so on. Right? So what we come to know here, if you know the first term and the common difference, then you can write the series, right? So let's see other way, okay? That is, when you know the series, that is arithmetic progression or not, how do you say? We'll just find the common difference. If it is not the same, the common difference, then it is not the arithmetic progression. Let's see some more examples in that, okay? I'm writing the sum of the some other series here. 6, 3, 0, minus 3. Let's see this is arithmetic progression or not, okay? So what is the first term in this arithmetic progression in this series? What is the first term in this series? That is A1 is equal to 6. What is the second term? So we are calling these are the terms, right? The first term, second term, third term, fourth term, and so on. Okay, what is the second term? 3. What is the third term? 0. What is the fourth term? It is minus 3. So how do we find the common difference? Common difference can be obtained by subtracting A2 minus A1, right? So between these two differences, right? That is 3 minus 6, right? That is also minus 3. Okay, you got minus 3 is a common difference between if you subtract A2 minus A1. Let's find for the another, okay, like A3 minus A2. Then 0 minus 3, that is also minus 3. Okay, let's find the common difference between A4 minus A3. That is minus 3 minus 0 is equal to minus 3. So you can observe from all this series here so far, it has the same difference, minus 3. So it has the minus 3 is the difference between the two numbers. So this is called arithmetic progression, right? So the condition, if it is satisfied, common difference is same, then that series we are calling arithmetic progression. Now we will see general form of arithmetic progression and nth term for the arithmetic progression. Okay, so let's write the real numbers starting with the 1. Okay, 1, 2, 3, so on. I'm just writing up to 100 numbers. Okay, so we cannot write an entire 100, so that I'm just keeping the dots. 2 consecutive numbers, and it has the common difference or not, we need to check. Okay, so we know that this real numbers 1, 2, 3 up to 100 is the arithmetic progression, since it has the common difference of 1, right? So 2 minus 1 is 1, 3 minus 2 is 1, so 1. Okay, now in generalized format, how do I represent, right? Each term I am representing with the alphabet small a letter. Okay, so the term I will represent with suffix with 1. Okay, so A1 I am representing the first term in this series. Okay, that is 1. Okay, A2 I am representing the second term in the series, that is 2 here. Okay, similarly A3 is representing in this series is 3. Okay, how many terms it has? It has up to 100, right? So the 100 term or in this series it is the last term, right? 100 is the last term. So in A 100 is equal to 100. So the suffix I will represent the which term we are talking about. We are talking about the first term, second term, third term. Okay, so the generalized format of the series can be written as like A1, A2, A3, so on. And this series having the 100. Okay, it has 5 numbers, 10 numbers, 20 numbers, 30 numbers, or 50, 100, 200, 300. Okay, that's the reason I'm just generalized format here A n. Okay, so this arithmetic progression has the n numbers. Okay, so in this series 1 to 100, what is the n? N is equal to 100. Since it has the 100 numbers. So in the generalized the number for the last term, that we are representing the suffix with n. Okay, so how do you find the common difference here? The common difference is either A2 minus A1 or Also you can write A3 minus A2. Okay. Addition numbers you can write like this. Okay, like A2 minus A1 or A3 minus A2, like that. Let's take on the way of the series, we have the another number like AK. Let's take the AK is the sum number in the series. Okay. So next number to the AK is AK plus 1 number, right? So here also you can write the common difference like this. AK plus 1 minus AK. K is the which number? That we don't know. Somewhere in between the series. For example, here that K may be 50, 40, 30 or something like that. Instead of writing the first two, it may be the any number, right? K may be the anything. Like that. See, for example, this common difference, I'm just writing like K plus 1 minus AK, right? Let's take the second term. You can write it like this, okay? A3 minus A2. Here K is equal to 2, okay? So that K may be the anything generalized term on the series go, okay? That's the reason we have written K here, okay? Let's write the generalized form of the series, okay? That we learned just before, that I'm writing like A1, A2, A3, so on, AN, okay? So this is first term, okay? First term, this is second term, okay? This is third term, and so on. This is nth term, okay? Nth term. That means nth number. That may be the 100 number, 200 number, 300 number. That we do not know. We have written the generalized format, right? Okay. Let's take the D as the here common difference, right? So let's take D is equal to, let's take the common difference. Okay. Now let's take the first number is equal to A. Let's take the A as the first number in this series. Okay. That's why I'm writing A1 is equal to A. Okay. Then how we can write first number here? A1 is equal to A. Okay. How do you get the next number in the arithmetic progression? Just adding the D to the previous number, we will get it, right? So that the next number will become A plus D, right? How do you get the next number to this one? Just adding D to the previous number, right? So that here A plus D is the previous number, okay? Again adding the D, right? So and so. So that, okay, I'll read again. Let's say I'll write the nth number little later to understand yourself better, okay? So what you can write here? A comma, here the next term is A plus D, the next term is A plus 2D, and so on, okay? So here this is the first term, this is the second term, this is the third term, right? So I'm rewriting these numbers one more time here, see. A is the first term, right? So, comma, A plus, so D I'm writing here, this is the second term, minus 1 into D I'm writing, okay? So that it will become 1D, right? And the third term I'm writing A plus 3 minus 1 into D, okay? And so on, okay? So why I'm writing like this? When we are calculating the second term, we are just adding the 1D, okay? One common difference, okay? One common difference we are adding. So how we are getting one common? Because this is the second term. So the previous number is the first term, right? That's why you have only one common difference. But when you are going to third number, you have the two common differences need to add it. This is the one common difference and this common difference, okay? That means when you are writing the third term, when you are writing the third term, you are adding the two common differences, right? Always one less common difference you are adding. When you are talking about the second term, you are adding the one common difference. When you are talking about the third term, you are adding the two common differences. Okay. Similarly, when you're talking about the nth term, you're adding n minus 1 common differences, right? That's the reason we are writing nth term as a plus n minus 1 into d. So, n minus 1 d common differences we need to add. I'm writing here 2, 4, 6, 8, 10. Okay. I just written the 5 numbers. So, here common difference is d is equal to 2. Okay. For the first term, we'll write as it is. Okay. The second term, you need to add one common difference to the first number, right? So that 2 plus one common difference is 2. Okay. But when you are writing the third term, you need to add the two common differences. Why? Because this is the previous number you added already one common difference. You need to add the addition one more common differences. So when you are writing the third term, you need to add two common differences. Okay. But when you are writing the fourth term, you need to add the three common differences. 3 into 2. Okay. So if you see here, this is a 2 and 2 plus 2 is 4. Again, 2 plus 4 is 6. Again, 2 plus 6 is 8. Okay. You will get the same series as above. Okay. That is the reason when you are writing the nth term, you need to add the n minus 1 common differences. Okay. That's called n minus 1 into d you need to add. So here we learn about the nth term. Okay. Nth term is a plus n minus 1 into d. Okay. Here d is the common difference. What about the a is the first term in this series. Okay. N is nth terms, n, this series has the n terms. Term is the number. This is the first term, second term, third term, like that. It has the n terms. Okay. So here n is the nth term. Now we'll see some of the examples to understand. Okay. Find 10th term of AP 2, 7, 12 and so on. Okay. So he is asking 10th term of the arithmetic progression here. So here he has given the arithmetic progression 2, 7, 12 and etc. Okay. So how do you find the 10th term of the arithmetic progression? It's like, right, earlier I said, right, the nth means the generalized format. That may be 10, 20, 30, 40, you can find out. Okay. Let's see what is the first term in this arithmetic progression. Okay. First we'll check whether it is the arithmetic progression or not. Okay. How do you find it? You just see the common difference between the two numbers. Then you will see is it arithmetic progression or not. Okay. Let's see the given arithmetic progression is 2, 7, 12, etc. Okay. Let's take the common difference. Okay. That is 7 minus 2 is equal to 5. See another way, another common difference we find between the third term and second term, 12 minus 7. That is also 5. Okay. So it has the fixed difference. Then this is arithmetic progression only. Then we need to find the 10th term for this, right? So the starting term, we know, starting term is 2, right? That is A1. A1 is 2. Okay. Earlier I said, when you are finding the nth term, okay, nth term, you need to add you need to add n minus 1 common differences to the first term, right? N minus 1 common differences to the first term. Okay, that is nth term I am writing here. Nth term I am representing as like an. Okay, nth term. What is the first term I am representing as like a, right? We need to add n minus 1 common differences, right? So we know the first term here, right? That is 2 plus. So we are trying to get is nth term as the 10th number, right? That's called an. a suffix, you can write A10. Okay, this is called 10th number. When we put it 10th number, 10 minus 1, what is the common difference here? 5 is the common difference. That is 2 plus 9 into 5. Okay. So 2 plus 45. So that's equal to 47. So here in this series, 10th term is 47. Let's see the another problem. Okay. Check whether 301 number comes under arithmetic progression of 5, 11, 17, 23. Okay. So we have one arithmetic series here. The question asked, right, 301 number will come in this arithmetic series or not. Okay. Let's find out how do you find it. Okay. Let's see what is the given. Whether first we will check whether this is arithmetic progression or not. Okay. First we need to find the common difference. That is 11 minus 5, 6, right? Okay. So let's check another number, like 17 minus 11 is equal to 6. Then third, intersect 23 minus 17. Okay. So 6. So this is arithmetic progression. Right? Now, what is the first term in this arithmetic progression? A is equal to 5. Okay. So this 301 is, let's take, this is the nth term. Okay. So always in the mathematics I'll tell, right, whichever we do not know. Okay, we'll assign a orbital variable or some kind of alphabetically we'll assign it. Okay, later we'll find that number. Okay, let's take this the nth term. Okay, nth term is 301. Okay, so how do you find the nth term in the series? Let's take how do you find the nth term series. Okay, you will just add n minus 1 common differences to the first term, right? So this is the nth term. That is called an. Okay. Here n we do not know what is the nth term. Okay. We need to find the nth term. Okay. What is the first term in this series? Okay. 5 is the first term. 5 plus, we do not know what is the nth term. Okay. That is 301. We do not know n minus 1 into, what is the common difference? We have the 6 here, common difference is equal to, what is the term in the series is given? 301, right? 301. Okay. Let's simplify this one. 5 plus 6n minus 6 is equal to 301. Let's keep 6n one side and send other numbers. So the other side. So 301. So minus 6 plus 5 is minus 1. If you go to the side, it's a plus 1, right? Plus 1. So n is equal to 301 plus 1 is 302 divided by 6. Okay. This number is not positive integer, right? So it will come into decimals. If you divide with this one, you get 5 and then 0.3 you get, right? So it is not perfect division with the 3. Okay. That means this 301 will not come into this series. Okay. If it is coming into the series, n number should be the positive integer, right? Positive integer. So the number should be like 1, because this is the first term, second term, third term, fourth term. Like that we are defining this series numbers, right? How it will be 50.3 number? No, right? There is no meaning in that, right? That's why the 301 number, it will not come into the series. Now let's talk about the sum of the n terms. Okay. So before we are talking n terms, I'll try to explain very simple logic here. Okay, that you'll understand very well. Okay. For example, one series I am going to write here, a very simple series. Always I'll write the real numbers. Okay, to understand very easy way. From 1, 2, 3, 4, so on, so up to 100 I am writing. Okay. So how many numbers it has? it has the 100 numbers, right? 100 numbers it has. Okay. Then just I want to find out total 100 numbers. Okay. Some of these 100 numbers I want to find out. Okay. You feel it's very tough, right? And very difficult, or so you need to use some calculator or you need to write something, right? I will show you a very, very simple method, okay, to make it sum of these 100 numbers here. Let's take the S is the sum of these 100 numbers. So I'm rewriting the S is the sum of here 100 numbers is 1 plus 2 plus 3 plus 4 plus so on plus 100, right? So here what I am writing, right? I am writing here one more S in the reverse order, okay? The same numbers I am writing the reverse order, okay? The same 100 I am writing in the starting, okay? 100 plus 99 plus 98 plus 97 and so on plus 1, okay? My last number here is the 1 and first number is the 100, okay? In the first expression, first number is 1 and the last number is 100, okay? So this is how many numbers it has. It has the 100 numbers. This is also having the same 100 numbers, right? This is also having the same 100 numbers, but I have written the two numbers. So what I will do, I will try to sum up this. I will try to sum up this one, okay? Because it's equal signs, okay? I'm just summing up the left side one and the right side one. It will not change anything, okay? If I sum up the S and S here, we'll get the 2S here, right? Similarly, I'm trying to sum up here these two, okay? Let's sum up the here 1 and 100, okay? This is 1 plus 100, okay? This is the one thing. Plus, I'm writing here 2 plus 99, okay? Similarly, I'm writing 3 plus 98, okay? And so on. I'm again writing the last one, that is 100 plus 1, okay? So I'm just in the brackets, I'm putting the 1 term, okay? So here adding 1 plus 100, it became the one bracket I'm keeping here, like 2 plus 99 on one bracket here I'm keeping, right? So how many brackets will be having? Here this is having 100 numbers, this is also having 100 numbers. So each one I'm keeping into the one bracket, okay? Like 1 plus 100, 2 plus 99, like that. So this is also having the 100 brackets to have. Okay. So let's rewrite here. So 100 plus 1 is 101, okay? Plus 99 plus 2 is 101, right? Plus 98 plus 3 is 101, okay? So all are 101, okay? The last one is again 101. So how many 101s we have? So 100 101s numbers have, okay? So we have the 100 101 numbers, okay? So how do you can write this one, okay? We need to add 101 100 times. Always I said times means that is we need to multiply. 100 times we need to write the 101, okay? Simply I am writing here 2 into 2 means you need to add 2 into 2 times, okay? That is 2 plus 2, okay? 5 into 4 means you need to add 4 5 times. 5 times 4, this indication is 5 times 4. That means 4 you need to add 5 times. So what is the 5 4s are? It is 20, right? Here also will get 20. You see 4 plus 4 plus 4 plus 4 will get the 20. So that means 101 is having 100 times, okay? That's why 100 times 101 we have. So 100 into 101. So then what is the S? Okay, S is written 100 into 101 divided by 2. So how simple it is, you see here, to find the sum of the 100 numbers here. It is simply 100 into 101 divided by 2. 5050. Now let's derive the sum of the n terms. Okay. So I am writing a arithmetic series. Okay. That is A1, A2, A3, so on, AN. Let's say this is the arithmetic series. Again, I am rewriting the same arithmetic series by using the common difference and first term of the series. Okay. Let's take the first term of the series is A and common difference is D. Okay. So first term can be written as A. Okay. This is the first term in the arithmetic progression. The second term A2 can be written as A plus D, right? Then third term, how will you write? When it is third term, we need to add the two common differences. When the second term, we need to add the one common differences, like A plus 2D, and so on. Okay. How do you add for the nth number? Nth number, you need to add the n minus 1 common differences. You need to add. So n minus 1 into D is the called nth term in this series. Okay. Now, how do you do here? We need to find the sum of these n terms. That I am representing Sn. S is the sum of the n numbers. N is the n terms, okay? N terms in the series. So I am writing Sn, okay? Here what I will do, I will just sum up the everything, okay? So to avoid the confusion, I am just putting the brackets for the each number. So A is the first term plus A plus D is the second term plus A plus 2D is the third term. So, what is the nth term here? A plus n minus 1 into D is the nth term, okay? So, how many numbers we have here? How many terms we have here? We have n terms, right? So, this is having the n terms, right? So, as I said in the previously, I am again rewriting this Sn, okay? In the reverse order, okay? Let's take this is the equation number 1, okay? I'm writing the same in the reverse order. First, I'll write the nth number here. That is A plus n minus 1 into D. I'm putting a little bit bigger bracket. We have the another here, right? So, plus, what is the next one? This is the nth number. What is the n minus 1 number? It will become n minus 2, right? So, here I am writing A plus n minus 2 differences, okay? And so on. What is the last number? Last number is A. Okay. Let's take this is the equation number 2. Okay. Now, as I said earlier, right? So, we are going to add these two. Okay. Then we will get the left side. Sn plus Sn is 2Sn. We get it. Sn is the sum of the n terms, right? So 2 into Sn will get it. I am trying to sum up the each one here, right? I am writing with the bracket. So here A is there. A plus, this is A plus n minus 1 into D. Okay. So I will write only another term, one more term here. So here A plus D and here, right? So A plus D plus A plus n minus 2 D plus so on. The last one I'll write it like this, okay? Like same A plus n minus 1 into D plus A. Okay. So I'm just adding one term from here, one term from here. Okay. So how many numbers we have like this? The same way we have the n terms we have here also. So n terms are n numbers we have here. Like this. That each bracket having one, like the n brackets we have. So is equal to, I'm just simplifying the bracket here. So here A plus A is equal to 2A plus n minus 1 into d, right? Plus, if we simplify this one here, okay, here also a plus a here is there, that is 2a, plus here n minus 1d plus d, okay. We need to subtract the 1d here. So here I am just writing here to not to confuse here. So it is n minus 2 into d, right? Plus d, right? So here n into d, if you put it, nd minus 2d plus d again here. So minus 2d and plus d, again single d it is, right? Minus d, again if you take d as the common, become n minus 1. So here again n minus 1 into d and so on. If you write the last term here, again this a plus a is 2a plus n minus 1 into d. How many brackets or how many terms we have here? We have n terms, okay. So you can check it here. Each bracket will have the same number, okay. So how many times it has? It has the n times. So we need to add the n times this one. So it is simply n into 2a plus n minus 1 into d, right? I will erase this. So I am writing here Sn is equal to, so here 2 if I send it to other side, it will become like n by 2 bracket 2a plus n minus 1 into d, okay. So this gives the sum of the n numbers, that is n by 2 into 2a plus n minus 1 into d. Let's rewrite the expression. We got the sum of the n terms, okay, that is called Sn, means sum of the n terms we are writing like n by 2, 2a plus n minus 1 into d, right? So this will give the sum of the n numbers into the n numbers of the arithmetic progression, right? So I am rewriting this one in one more way, okay, let's see. So n by 2 bracket, this a is the first term, right? I am splitting this one a plus, again a plus n minus 1 into d, right? Bracket. So the a is the first term. What is this one? This is the nth term, right? Nth term is the just adding the first term to the n minus 1 differences. So this is the nth term, okay. So nth term in this series we are calling this like last term, right? Last term, right? That's the reason this one can be written like n by 2 a plus and a n. N is the nth term, or an is also called the in this series like last term, right? Last term from the series, okay. So we can write it this one like, right, n by 2 of first term and last term. It's a plus l also can write it, or simply, okay. L is the last term, a is the first term. So now we know in the arithmetic progression, the starting number, common difference and nth number and sum of the n numbers. Let us take one example problem here. Okay, here first write down the what is the given, okay. Then what you need to find out, okay. Then you will understand always the problem very clearly, okay. First read the problem, try to write what they are given, okay. Even you don't know how to solve it also, and many of the problems my tip is first write down, okay, what is given, okay. Then what he asked for. Then you will get the real understanding how to solve the problem, okay. The first and last term of the arithmetic progression 17 and 350, right, respectively. If the common difference is 9, how many terms are there and what is their sum? is given. Okay. So let's write. Okay, I need to write these steps to understand, but I'm just denoting with some. You need to write these steps to understand better. Okay. What is the first term is given? First term is given 17. Okay, we will represent A as always first term. Okay, and what is the last term is given? L. That is 350. Right. So we know first term and the last term. What is the common difference? Is the 9, right? So we can write this series here actually. You know the first term and difference, common difference means you know the series. Okay, what is the series then? 17 plus 9. Plus 9 is how much? It is 26, right? 35, etc. And the last term is 350, right? I think you need not write the series to better your understanding. I just written the series, okay? So this is the series, okay? So what he asked here, how many number of terms are there in this series, okay? So let's take, this is the nth term, okay? Okay, let's write the nth term, okay? How do you write the nth term? Nth term I'm representing is with an, okay? So for the first term, you need to add the n minus 1 differences, right? So what is the first term here? 17. Okay. You do not know what is the nth term here. That's the reason I just keep the n as I do not know. What is the common difference here? Common difference is 9. Okay. So what is the nth term here? an. An is given as 350 here, right? So let's put the 350 here. So from this equation, you will get n minus 1 into 9 is equal to, this 17 goes to other side. So 350 minus 17. So this is 333. So n minus 1 is equal to, we need to divide it like 333 divided by 9. So n is equal to 37 plus 1, so 38. Okay. So this series has 38 terms. 38 terms this series has. Okay. So what other things he asked for? He asked for the, what is the sum of their sum, okay? We know that the sum can be written like this, okay? Sn, right? Sn is the sum of the series that can be written with n by 2 into first term and the last term, okay? So simply, so what is the n is the, how many number of terms we have? We have 38 divided by 2. The, what is the first term here? 17. The last term here, 350, right? If we simplify this, 6973 will get. Okay. Now we will know that it has 38 terms and the sum of the 38 terms is 6973. I will create another video for solving more problems. If you need any specific problem, you can write in the comment section. And please don't forget to subscribe my channel. Thank you.